Okay, in this video, I'm going to show you how to find the arc length of the curve y equals e to the x from 0 to 1. Our arc length formula says that that's going to be the integral from 0 to 1 to the square root of 1 plus e to the x squared dx. Remember, the arc length formula is integral from a to b, 1 plus f prime of x squared dx. And f prime of e to the x is just e to the x. So this is just a side note. And so start off with this integral. Well, immediately off, it doesn't look like there's anything we can do to it. But let's first multiply by e to the x over e to the x. So we get the square root 1 plus e to the x squared e to the x. This is an e to the x over e to the x dx. Now we have a derivative and a function. The derivative of a function times the original function. So we can set u equal to e to the x. Du is equal to e to the x dx. So we have the integral square root of 1 plus u squared times du over u. Now we've got to change our limits of integration. E to the 0 is 1, and e to the 1 is e. So that's our limits of integration. Now this is a bit more of a solvable integral, because this looks like a trig sub. We can have u squared plus 1, so this is the tangent trig sub. So u is equal to tangent t. Du is equal to secant squared t dt. So now we get to, sorry, I had to resize my canvas. So now we get to substitute in. So we have the integral square root of 1 plus tangent squared t secant squared t dt all over tangent t. We've got to change our limits of integration again. And we're going to solve for t. So t is equal to tan inverse of u. And tan inverse of 1 tan inverse of 1 is pi over 4, and tan inverse of e is simply tan inverse of e. There's no simplification of that. So now what we do is simplify. This is simply secant t. So we get integral from pi over 4 to tan inverse e of secant cubed t times cotangent t dt. Now, this can be simplified. Pi over 4 tan inverse of e. Secant cubed is simply 1 over cosine cubed. Cotangent t is cosine t over sine t, so we have secant squared t times cosecant t dt. And we're now ready to hit it with, what does this look like? Well, integration by parts. So we have u is going to be cosecant t du is negative cotangent t cosecant t. dv is equal to secant squared t. So v is equal to tangent t. So we get this is now equal to tangent t cosecant t evaluated from pi over 4 the tan inverse of e minus the integral from pi over 4 to tan inverse of e of v du, which would be minus, that changes to a plus, cotangent t tangent t cosecant t dt. And of course these cancel out, and we're left with tan t cosecant t evaluated pi over 4 to tan inverse of e plus the integral from pi over 4 tan inverse of e cosecant t. Well, how do you find the integral of cosecant t? Well, you multiply by cosecant t plus cotangent t divided by cosecant t cotangent t dt. So we can evaluate this to be, this is simply secant. So you get secant of t evaluated from pi over 4 tan inverse of e plus the integral from pi over 4 tan inverse of e. This is cosecant squared t plus cosecant t cotangent t over cosecant t plus cotangent t dt. Well, now we can set u equal to the bottom, cosecant t plus cotangent t. du is equal to cosecant t, cosecant squared t plus cosecant t tan t cotangent t. Actually, this is a minus, and this is a minus. It's the one thing you have to remember when taking derivatives of those cofunctions. So this goes to minus. So we end up with, now it looks like I'm going to have to cut this off due to a time constraint. I'll be right back, and I'll continue this in the next part.